x, but not from, right?
Well, but an x, because it has that extra variable x, and you're allowed to pull constants out front, but you can't pull variables out front. So.
And it's not arc sign because it's not one.
Yeah, but then it gets you can't do it.
Yeah, it's not arc sign.
All right, so here's the problem. Okay, try to hang with me here for we got 10 minutes or so. Unless you gotta go, then you gotta go. But you're gonna miss this cool stuff. Where are you going? Everybody's gotta go. Well, I guess that's true.
It's a different schedule today over at the high school, so we guys get out.
Okay. This is good stuff. So, this is an integral we'll learn how to do in Chapter 8. In this class, we learn some advanced integration techniques, and we'll learn how to do some integrals that we don't know how to do yet. And we'll learn an advanced technique to do this problem, and it'll take about a page or half a page to do it. Okay. But at the moment, what we could realize is this, that if we graph this, it's a function. It's y equals the square root of 9 minus x squared. If we graph that, maybe we know what it is, maybe we're just learning what it is, but it's a semicircle. It's a semicircle of radius 3. Sort of, that was kind of the idea here. This was radius 1. So it's a semicircle of radius 3. You're integrating from -3 to 3. An integral, even though we're starting to learn to use integrals for volume and all kinds of other stuff, one way to interpret an integral is that it's the area under a curve. So if you realize that this curve is a semicircle and you're integrating from -3 to 3, then you might realize all of a sudden that this answer to this integral, using some geometry, is the area of a semicircle of radius 3. Do you know the area of a circle? Pi r squared. This is half a circle I just suggested, so it's over 2.
So it's 9 pi over 2.
So it's 9 pi over 2. I mean, this is the answer to this integral, not using calculus, using algebra and geometry. I realized that this is the area of a semicircle of radius 3. Bam, there's the answer. And they say that that idea pops up in this problem. That's what they say in the little hint. How did they say it in their hint? Hint, the integral from -1 to 1 of a square root of 1 minus x squared is the area of a semicircle. That was their hint. Will that, now wait a minute, is that actually what I have? No, but if I do some distributing and cleaning, here, let's work on this a second. Let's see what happens. I think, can I just take, this is one quantity, can I distribute it times the 2?
Right.
So I will have 4 of those square roots.
Right.
Minus, if I distribute it times the x, then it's -2x times those square roots. You guys okay? I need to think of this now, I think, as 2 separate integrals. I have this integral. I'm going to pull the 4 out in front of this integral. -1 to 1, the square root of 1 minus x squared dx. That's one integral. With the 4 out front, how you doing? Y'all okay?
Yeah.
And then over here, I got a different integral. This is 2x in front of the square root of 1 minus x squared dx from -1 to 1. Okay, here we go. That integral. Can you do that integral?
Yeah.
Yes. You can do U substitution and do that integral. You can do that integral.
Yes. Yep. Yep.
You know what? I think when it's all done, the answer is 0. But you can do it.
Serious?
I think so.
Okay.
Watch this. Can you do this integral? And the answer is you know. You haven't learned the technique to do this integral yet. But you did just learn that you can interpret it as the area of a semicircle of radius 1. So hold on. There's this 2 pi out front. There's this 4 here. And now I'm calling this the area of a circle, a semicircle, of radius 1, which would be pi r squared over 2. The r is 1. Like I said, I could go do that integral for you or with you. You could also do it with u substitution. I think the answer is 0. Here, let's just work on this little guy. Let's work on this little guy. Your mark, get set, go. Let u equal 1 minus x squared. What's du? Negative 2x dx. When I replace all that crap, it turns into a square root of u du. I think. With a negative sign out front, which is going to hit that negative sign, if you don't mind, and make it plus. If you don't mind. How do you do a square root of u? It's u to the 1/2. How do you do u to the 1/2? U to the 3/2 times 2/3. And then what's my u? My u is 1 minus x squared to the 3/2. And then I'm going to plug negative 1 to 1 in there. Remember, you guys? Watch what happens when you plug in a 1.
Oh, it's 0.
When you plug in a 1, it's a 0. Minus, what happens when you plug in a negative 1?
0.
It's a 0. I mean, that's interesting. That whole half of the problem contributed nothing to the volume. It's a 0. That's the integral we could do, and it didn't help. I mean, it contributed nothing to the volume. It turned out, I mean, here's the answer.
Basically.
Right here. It's a beautiful little answer. Those 2's cancel. It's a 4 pi squared. That is wild.
Yep.
That's the volume of a torus.
Oh, wow.
Of radius 1.
Volume of the torus.
The torus is radius 1. It also, what's the radius of its hole? Well, it changes, but it's kind of 1 if you thought about you're spinning it around. Right? I'm thinking the hole, or that part of the hole has a radius of 1. Mm-hmm. The donut itself has a radius of 1. And that's its volume. It's kind of interesting how you get that pi squared. I mean, it kind of makes sense to get a pi squared? I mean, you got circular motion this way. I mean, maybe you found this area. The way that's pi r squared. And then you multiplied it by some sort of circumference, which involves pi. I mean, you have a circular region, and then you're rotating it in a circle. You create a couple of pi's. I'm trying to explain why we're getting a pi squared, I guess. Sort of explain, not really explain. Anyway, that was fun, and it's probably getting time to quit. So maybe we'll quit. Why don't